How are you?
All right.
I was looking at this thing yesterday.
Yeah, so this is it started life as a liquid handling robot, and
liquid handling robot.
Right. So basically, you had a couple of like syringes or pipetters on there.
All right, hang on.
Yeah.
Let's start all over.
Okay.
All right, because I want to make a video.
Oh, okay.
You cool with that?
Yeah, that's fine.
All right. I'm Matt.
Paul.
Inside the Mind of Matt.
Okay. Yeah, I've seen some of your videos on there. Yeah.
So I'm here with Paul, and he's got this interesting machine, and he's going to tell us all about it. So,
okay.
What do you got?
So what I have here is what I usually say is it's a resurrection job, because this started as a liquid handling robot that was meant to pick up liquids and transfer them into different tubes and locations. So this was originally purchased for a government lab, and the cost of this instrument was probably near $30,000. And I found it in a government surplus facility and decided it had this really kind of unique Z-axis on it. And I thought this is something that I could maybe turn into a 3D printer. So I've done that, and I've tried to use as many of the original components as possible. So instead of using stepper motors, it actually uses DC servo motors for all three of the Cartesian axes. The only stepper motor is an extruder motor. All I've really done is I've added a hot end on here. I've added a ramps board, so everything's contained within this massive X-axis. So there's essentially a ramps board in there. There's Arduinos that are on a PCB on the back that deal with the closed loop control for the system. And if you get down here, one of the neat things about this DC servo is I can actually grab this whole axis and move it, and it'll return to the proper position. So I will ultimately lose steps. So,
okay.
So here's an example of if you grab this and move it over, it just goes back to the appropriate position. I can do it again. So everything's contained in this X-axis here. It's got a ramps board that's on the inside. All of the DC servo motors are in here, and it has this one stepper motor that's here. The thing that makes this not a great design is that there's a lot of flex in these rods here, and that's actually part of the original design of the robot, just so that if it's not perfectly lined up, it would flex when it had to go to a certain position. So in that sense, it's not a very good design, but you do get some unique things from this, including this whole idea that because there's a closed loop system, you can just grab an axis and move it, and it'll go back to the original position. So the Z-axis on this. So it has an encoder in the back, so it knows the position. And this is the DC motor. There's a planetary gearbox on this to give it more torque. But back here, each of these is an Arduino that's actually controlling. It knows the position that it needs to be at based on the step and direction from the ramps board. So it'll basically send it that information, and it's just a number on the encoder. So the encoder knows what number it needs to be at. So if it's off, it'll move back to that number. So it can't lose steps in that sense. Now, that's not entirely true. It actually will lose steps. Like, if you hold it in place, because it's sending G code, it doesn't know to stop the G code.
Right.
What happens is that you'll eventually end up, and actually, I think
this looks
yeah,
like
that's exactly right.
So what's the actual Z height on this?
The Z height's 240 millimeters.
240 millimeters, and then
635 in X and about 320 in Y.
And what's the biggest thing that you've printed?
The biggest thing I printed is a Stormtrooper helmet in one piece for that guy down there.
Nice. I have a complete Stormtrooper costume that I've printed, so, and I did most of it on the CR10. So
yeah, CR10s are great. I mean, this is not going to give you like super high quality prints, but it's not bad for
no, that's actually
conversions.
Not bad. Very cool. Now, do you have, are you on social media with this, a YouTube channel, anything?
Not really.
Okay.
I'm kind of an old dude, so I don't do a lot of stuff. I have been looking at Twitter a little more often, so it's Paul Paukstelis is my Twitter handle. So.
All right, I'll make sure I look you up. Awesome, I appreciate you talking.
Yeah,
this is a prime example of, you can reappropriate anything into a 3D printer if you really wanted.
Yeah, I really like the idea of repurposing things. You know, it's there's so much stuff that gets thrown away, and when this definitely would have been put in a scrap heap if I had not grabbed it out of it.
And it's completely enclosed.
Not well, the top's not enclosed.
Okay.
So, but yeah, you can bring this down, and there are panels that go on the back. So if I wanted to enclose this, it wouldn't be difficult.
Okay.
There's no heated bed.
No heated bed, just mirrors with tape.
Yeah.
So. Very cool. And what would you say you got into this?
Price-wise?
Yeah.
Well, the whole thing was actually free.
Right.
There's some government surplus. And I think maybe, you know, less than $200.
And from start to finish, approximately how long did the project take you to actually get it to be able to print?
In its first form, it took me about 4 months.
Okay.
And then I sort of decided, I didn't really like that design, so it probably took me about another 4 months to get to where it is now.
Now, do you have a design, like, or is
No,
it just...
it's been very much a one-off process, so I've just been kind of like going, will this work? No, maybe not, I'll try this.
Gotcha.
So there hasn't been, it's been an iterative thing as opposed to like, this is the way that I'm going.
And is that the name?
That is the name.
Okay. All right.
In part because my daughter asked me, is that a robot? And I said, yeah. And she said, do you call it Mr. Robot? And I said, yeah, I do. But I like the TV show as well. So.
Very cool. Awesome. Thank you very much.
Thank you.
To actually help me separate the two heads and the pallet be on one, and theoretically